graphs. Okay, 4-5. This is the last section for this exam. Remember, I know you're stressed out. Remember, there's two types of stress. There's stress right now for the next 4 days. Try your best, and then you have a week off. Or there's carry the stress into turkey break.
Shh.
Right?
Start the lesson.
I am. This lesson, this is the last one. Don't forget, you do get your study sheet to use for the test. The stuff we're going to do in here, I would definitely put an example on the study sheet, because while none of this is challenging, it's a lot to remember. So I would use the study sheet to remember it for you. You stay with me? I've given you the tools to be successful. Use them. Oh, okay. 4-5 covers these topics. I know your guided notes don't actually have this slide. This is me saying to you, we're going to talk about domain. We're going to talk about vertical asymptotes, horizontal asymptotes, slant asymptotes, and finding the intercepts and other points. That is the entire lesson. Okay? Everything we're going to do to find this is stuff you already know how to do. Now I'm just showing you how to use it. Okay? Let's start with what we're learning about, which is rational functions. This slide you do have. Rational functions are graphs that come from fractions where there's an x in the bottom of the fraction. The mother function for all rationals is right here. This is the mother function for all rational functions. It's 1 over x. And then anything after that has been tweaked somehow.
Whether it's hard sugar or not.
Nothing. I'm not asking you to memorize any of these. I'm asking you just to know that rational means it's a fraction, there's an x in the bottom, and that's the mother function. That would be helpful. Notice there's 2 parts to the graph, right? Okay. Go to this slide right here. The first aspect of graphing rational functions is, can you state the domain? We have already been doing this since the Chapter R review. I planted it in the Chapter R because I knew how many times it was going to come up, because I was hoping you would get it and it'd be like, okay, I got this. I know how to do domain. Remember, domain is the set of possible x values that the graph will cover, and in this case, there is one particular value it cannot cover because we would have a problem with it. And what is it? We cannot have a 0 in the bottom, so what would make this particular function 0 on the bottom? If this was a 3, you would have 1 over 0, and that is bad. That is a no-go, right? Okay, so in terms of these problems, if I say to you, hey, find the domain of this rational function, you are going to set the denominator equal to 0 and solve. So x minus 3 equals 0. Solve it. I get x equals 3. Which means, y'all know how I use my arrow to say, like, okay, from this, I am concluding that x cannot be 3, right? Because if x is 3, I get a 0 on the bottom, I have a problem. So the domain of this function is, you can plug any number you want in here. Just don't plug in 3. Now how do I actually write it in the fancy notation? You can write it one of 2 ways. You can say that it's all numbers x, such that x cannot be 3. Or you can do the interval notation to say it's negative infinity up to 3, skipping over it to infinity. So I'm going to write domain right here. Like, this is my way of answering it in 2 different formats. I believe my math lab wants interval notation. So that bottom one. To write the bottom one, it's negative infinity to infinity, but you're going to skip over anything that made the bottom 0, right? move to the next slide. Just watch my slide. Coming back over here. Looking at the mother function. What number is off limits? 0 itself is off limits right here. Do you notice how when the graph gets to 0, it diverges, right? Like it won't touch it. And that's because there is a vertical asymptote at 0 that the graph cannot cross. What's the domain restricted value in the second one? Still 0, because what would make this 0? 0. Notice the graph diverges at 0. Is there an easy one? Right here. What's the domain restriction here? -1. Find -1. Notice the graph is diverging at -1. Okay? So that's putting the graph and the concept of domain together. Notice in this one right here, bottom middle, notice there's 2. One here, one here. You would take that and you would factor it. And you would have 2 restricted values. All right, go to this one. Practice. So that's how this entire packet is. I teach you, then you practice. I teach, then you practice. Which is why the packet is thick, because I put one question on each slide.
Practice drilling.
So find the domain of this one. Just don't sit up. You know, I don't know, last year I could have easily let the video run while people were trying, so it's probably not an hour and 20 minutes, it's just me talking. So that would be all. Okay, what'd you get?
Negative infinity to -4, again, -4 to infinity.
Very
You
good.
are so smart.
So you take the denominator, you set it equal to 0, you solve, and then you say to yourself, okay, so x cannot be -4. Since x cannot be -4, I'm going to represent the entire number line being shaded but skipping over -4. I give y'all, I did. Okay, so let's just sketch the graph here. I want you to, if you have a highlighter, it would really help with where we're going. I can throw you one, but I would like you to highlight
-4.
the vertical line that you found is off limits.
That's a pen, not a highlighter.
And then for now, we're just going to sketch. So the graph is here,
Glad you don't play football.
and there's not much you can do right here. There's not a lot of room.
Addison hit me in the head.
Here's what you do.
Anybody? Yep.
Eliminate off your face. My Fortnite battery outlet.
Anyone else?
Um,
Leading into the next topic, remember that very first screen? We said domain, vertical asymptotes, horizontal asymptotes, slant asymptotes, intercepts, and other points. We've now covered the first topic. We've covered domain. Leading into the second topic, vertical asymptotes. When you find the domain, you have found the vertical asymptotes. Bear with me, I'm going to say it again for dramatic effect. When you find the domain, you have also found the vertical asymptotes. Now they do get written totally different though. Same number, but the way you write it is different. Remember, domain is, hey, what does the graph cover? Right, so what's off limits in terms of skipping over the numbers? And then vertical asymptote is, what is the equation of the vertical asymptote? Well, I found the equation right there when I solved the denominator for 0. So this graph has a vertical asymptote. There is a silent P in asymptote at x equals -4. So let's go to the next slide where we're actually practicing finding the vertical asymptote. Just the vertical, not the domain. But what I mean by that is don't write the domain. You're just finding the vertical asymptote. All right, go here. Take your highlighter. Highlight. The vertical asymptotes are found when you find the domain. You set the denominator equal to 0 and you solve. The equation you get, like the value you get, is your vertical asymptotes.
Put it on the wrong one.
So here's our example. We are just finding the vertical asymptote. I'm going to start calling it VA, by the way. VA. So set the denominator equal to 0 and solve. So we have x squared minus 4 equals 0. Solve it.
Switch my graphs again.
You need to
Well,
white out.
it's fine. Because it's like pen and highlighters. There would be a lot of white out.
So
I'll just switch
just
it.
leave the graph alone, and then I can reprint the blank graph, and you can just take it over it.
It's fine. I'll just switch them. What? That's not why.
Yeah.
No.
Everything's backwards.
There's two unique. Two unique?
Huh? We're not solving for domain. When you find the domain, you found the vertical asymptotes. But for right now, I just want you to tell me what is it. I don't want you to write interval notation. You can if you want to. I'll do both. Just to keep you happy. All right. I'm going to add 4 to the right.
I think you just made Pierce really mad.
I'm not.
I'm 8.
You're not going to start worrying about me. Thank you.
Asymptote.
You come to x equals positive and negative 2, right? So how many vertical asymptotes will this graph have? 2. Take your highlighter, drop a vertical on negative 2. Whoa.
Whoa!
Sorry.
That looks familiar.
That was, all right. Drop a vertical on negative 2, positive 2. Y'all, shh. Lock in. You are not going to be the reason we don't finish.
I'm trying to, but you're
Get on the
like
bus or get left behind.
you're like walking back and forth and I can't see.
It's always her fault.
Yes.
Let's see.
He's had an interesting conversation with my uncle where Rusty sold.
He probably has an interest.
He was in the Vietnam War.
They were only
My
75
grandpa was
cents.
What? What?
We found the vertical asymptotes at x equals negative 2 and x equals positive 2. If you want to connect it with what we just practiced, you could also say, by the way, the domain here is negative infinity to negative 2. I'm going to run out of room. This is really going to go on. Union, negative 2 to 2. Union, no. Can't do it. We'll come down here and do it. 2 to infinity. So if I was to say to you, what is the domain here? It would have 3 different sections. Remember, it's the whole number line. You're just skipping over those values you found when you solved the denominator for 0. That's all it is. Well, we're going to get to that. For right now, we're just, I don't want you know what I mean? Like, since there's different layers here, for right now, do this. Throw a curve here. Throw a curve here. And throw a curve here. Because you have 2 asymptotes, you can see you have 3 sections, which tells you where your curves are. I am going to show you how to get the curves accurately. I don't want to show you that until the end. There's some more layers in here that we need to find out how to see before we worry about plotting the true curve. And you should be thankful that the exam is on my math lab because my students last year had to graph it by hand.
Yeah, I'd walk
I still have that test, and I've considered using it again.
It smells like
Good,
popcorn.
good test. All right. Is there another practice? Oh, no. Okay. The next one is, what if it's a special case? So let's go to this slide. Which means there's what in the graph instead of an
A hole.
It's a hole. You gotta know. You gotta know your asymptote from a hole in the graph. That would be a quote from Mr. Ryland. You gotta know your horse. It is his quote. You gotta know his.
Only be ever happened.
You gotta know your asymptote from a hole in the graph. All right. The point of this slide is if there's special cases, stay with me, stay with me, stay with me. Special cases would mean that something different is happening, right? But you still systematically approach it the same way. We need the denominator equal to 0, and we need to solve it. The difference is when the top will also factor, you need to have it in factored form as well so that you can see, is it a vertical asymptote or is it a hole in the graph? Regardless, the graph is skipping over it, but you do need to know the difference between am I dropping a highlighted section or am I just putting a big open circle? So look at this example right here. Let's factor the top and the bottom. Put it in factored form. What will the top factor to? Focus, guys, so you can relax Thanksgiving. And then the bottom's already a binomial in simplest form. Now do you see what's happening here? You see how this matches this, which means it's a hole. It's not an asymptote, it's a hole in the graph. Meaning the hole is a big open circle where the graph is essentially picking up and moving past it. Now the biggest question is, where is the hole? The hole's located at the value that would make that 0. So what would make that 0? 2. To get the y value of the hole, you're going to plug what you just said into what is left. And that would give you, so the hole is at 2, 3. All right, so let's take some notes. All right, so here we go. After I canceled the factor that matched, I was left with what? X plus 1. And then I'm going to make a note to myself with a hole at x equals 2. How do you get the y value of the hole? You're going to plug the 2 in to what was left. And we get 3. So the hole is at 2, 3. Now that's a lot to take in there, but it's nothing new. We've talked about a hole in the graph before. We just never graphed them. I don't remember what chapter. Might have been chapter 2, maybe.
Oh, it was like one.
Or 1. I can't remember. So it has a hole because it had a common factor. What makes it 0? Make a note of it. Write down what's left, because now that's what you graph. We're not graphing this. I don't want to graph that because half of it disappeared, right? It's a hole. We're going to graph this. That's just a line. It's linear. So you got to remember how to graph a line. Remember my phrase, begin with B, move with M? Yeah. B is
Plus 1.
1, that is the y-intercept. Move with M. M is 1 over 1, which is the slope, which means rise 1, run 1. Where's the hole? 2, 3. Rise 1, run 1. Rise 1, run 1. And now I can see the line.
Did you reply? If you put it in the calculator and you just go to the table, it'll
Say
shows
error. It'll just say error. Now, be careful though, because if it's a vertical asymptote, it will also say error. So you would have to hit graph, hit zoom 6, and you will notice that the graph does not diverge. Remember we talked about those beginning functions, how we said they diverge? It's like there's like some wall there and they're like, whoosh, nope, don't hit it. You'll notice this one doesn't have that, which is your indication, okay, it must not be an asymptote, it must be a hole. Graphs always just pass right through holes. They diverge at asymptotes. So that's the difference. If you want to use the graph as a checkpoint, a safety net. All right, let's do the next one. The next one does take a little bit of more work in factoring, but it's the exact same, applications. We have 2x squared minus 14x plus 20. What do you notice every single one of those has? Okay, so let's pull a 2 to the front, and that way let's just factor what's left. Don't throw the 2 away. It's still there. So we're not solving, we're just trying to look at it in factored form. All right, now A is 1. Beautiful. What are the factors of 10? Add up to -7.
-5, -2.
-5, -2. Because A is 1, we don't have to worry about reducing. Notice my thought process is, oh, this had a GCF of 2. Okay, so it's gone. Then I said, oh, this will factor. Okay, so this is gone. Now I'm going to keep my eyes up here. You see what I'm doing? I don't have a lot of room. If I had more room, I would probably write it out to the right. Now on the bottom, will this factor? 2. So now I'm going to mark this out because I don't want to get distracted.
Whoa. That's not bad.
Keep it your left ear.
Fierce.
Not an AirPod.
You like our Play-Doh?
Okay,
Sunday class.
what do you notice? Now you got to mute other stuff out, right? So try not to get lost in your work here. Try not to get lost in that. Focus on, okay, that's on the top, that's on the bottom. What happens again?
X minus 5.
There is a hole right there. There is a hole. We'll make a note to myself. Now I'm going to write what's left because this is getting crowded and confusing. So I'm going to come over here and I'm going to bring down the name of it. I'm and we'll bring down the top, and bring down the bottom that was left. And we said there is a hole. What would make it 0? A 5, right? If you set that equal to 0 and solve, you get 5. How do you get the y value of that hole? You plug the 5 in to what's left over. So that may take either a little bit in your head or on the calculator. So 5 minus 2 is 3 times 2, 6. 6 on top. 5 plus 1 is 6. 6 divided by 6. So the whole is that x equals 5, y equals 1. So 5, 1. Now, is there anything else still on the bottom though?
X plus 1.
That is not a hole, it's a, what did we just practice on the last slide? It's a vertical asymptote. So there is a VA at x equals -1. So there's 2 holes and a vertical asymptote in this graph. And all of that information came from, I didn't mean to say 2. All of that information came from just the bottom of the function. These do not happen a lot, so if this seems dense, this might be one you would want to put on your study sheet. It does not happen every time, but can it happen? Absolutely, it could. Alright, vertical asymptote at -1, and then a gaping hole at 5, 1. Now, in terms of where is the graph, for right now, we're still just sketching. It's here and here. Okay, you've covered 2.5 topics of our list of 5 topics. When I say 2.5, I mean you've covered domain, set the denominator equal to 0, that's what's off limits. That's what you skip over in the interval notation. You've covered vertical asymptote. When you set the denominator equal to 0 to find the domain, you have found the equations of the vertical asymptotes. Keep in the back of your mind, factor the top in case what you thought was a vertical asymptote was actually just a hole in the graph. For instance, looking back at this example right here, right? If I did not factor the top, I would have called x equals 2 a vertical asymptote when it's not. So you do have to keep that in the back, like put it in completely factored form, because then you can see the holes, and then what's left over is the vertical asymptote. In terms of domain, it's still skipping over those numbers. Doesn't matter if it's a hole or a vertical asymptote, it still skips over it.
This might be a stupid question, but I
What
didn't know before. When you go up, like in the direction that
How
you
did
go,
you miss?
how do you know that again? Like, how do you know whenever your graph goes up and then goes down?
I'm going to show you. We're not there yet.
Oh.
Remember me saying, I don't want you worried about the graph yet. I want to wait till the very end.
You
That
just worry
would
about
be,
the first part.
right now, I want you just worried about those first parts.
Oh, okay. I was like,
That
oh,
question
eliminate
will get
Pierce.
answered when we get here. Yeah. So we've done this, we've done this. Now we have horizontal and slant. The beautiful thing about these two aspects is when a graph has a horizontal asymptote, it means there is no slant asymptote. When a graph has a slant asymptote, it means there was no horizontal asymptote. So what I'm saying here is these two properties cannot coexist on the same graph. There's only one or the other. There's never both. You with me? And they are found in the same manner. You just answer the question of was it an HA or a slant? Okay? Are y'all ready to look at it?
Well, let's just finish today. Let's do it.
Well,
Can
I
you stop throwing stuff at Pierce, please?
Why are you
I
throwing
think-
stuff at me? First, you destroy my Play-Doh monument.
That was probably to save me from being uncomfortable. Because I didn't see it, but I'm sure it was uncomfortable. Thank you. Thank you.
Where's
for
your
you.
classmate?
Time.
His name was Johnson.
Can we do it?
He also went by
Yeah,
Hugh.
we
His last name was
Yeah,
Janus.
he has a lot of nicknames.
I don't remember anything.
Willie Johnson.
All right.
Big Billy.
Sausage.
Richard.
Quibby.
We are looking now at horizontal asymptotes. The nice thing about the horizontal asymptote is it is a test of the leading terms and the coefficients. So the math involved here is actually a trick. Does that make sense? You just have to read it. And then you just have to know, oh, it's less than, oh, it's greater than, oh, it's equal to. Okay, so we're going to try one of all three. If you don't pay attention here, this is so simple, short, and sweet, I will lose you and you would miss an easy question on the test. So this would definitely be something I would put on my test study sheet, like, because there's 3 categories. You know what I mean? Don't write that down. I'll show you a way to organize it later. But I would definitely put this on there. All right. We're looking at when is there a horizontal asymptote. If you come back here, you don't have to put this on yours, but there's one about right here. Do you notice how the graph diverges out as well?
Yeah.
There's a horizontal asymptote. All right, here's the math behind it. You simply look at the degree of the numerator and the denominator, and you compare them. So it is the degree of the numerator. If it's less than the degree of the denominator, then the horizontal asymptote is by default every time y equals 0. If the degree of the numerator is less than the degree of the denominator, then the answer is yes, there's a horizontal asymptote and it's y equals 0. Moving on. That can be done.
So this one right
I
here.
told you it's simple, so watch. So they are always in descending order already, by the way. There's no reason to mix them up, because that'd be a gotcha. They're going to be given to you in standard form, counting down. The degree here is 1. The degree here is 3. Let's pull it over here. We're going to put leading terms. And we're just going to focus on them. I've got 2x to the first power over x to the third power. Is 1 less than 3?
Yes.
Then there is a horizontal asymptote at y equals 0. There's no other math to do. It is just a leading terms test of the degrees. That's it. Now, there's 3 scenarios, and this is kind of what I was getting into, like when I said, oh, I don't like that. This is kind of what I was getting, I'll get it, hold on. That's still not bad. All right. This is kind of what I was getting into when I said that you should organize it by 3 scenarios. You've got when the numerator is less than the denominator. I think the next one is equal. Let me make sure I do these in the same order. Yeah. You've got when the numerator is equal, and then you've got when the numerator is greater. So those are our 3 scenarios here, and we're going to practice one of each. So when the numerator is less than the denominator, bam, the answer is y equals 0 every time. When the numerator is equal to the denominator, I want to go ahead and tell you the shortcut right here, but then we're going to go to the next slide where we actually practice it and take notes. It is y equals, now be careful here, I'm just going to put number over number because it's the coefficients. It's the lead coefficient of the top over the lead coefficient of the bottom. So I was going to do a over a, but then I was afraid somebody would say, oh, those kids want to get one. Don't do that. So I'm going to show you what it looks like. All right.
Really, A sub 1 is.
You could. That's probably more accurate than number over.
Well, what's the
Or you could do
third one?
LC. I'm not doing it yet. I'm going to do this one. All right. Go to this slide. When the degree of the numerator and denominator are equal,
Here's turnaround page.
then the horizontal asymptote is the equation y equals, and then it's the leading coefficients. Just the numbers. So for instance, right here, we have our leading terms. Negative 7x to the fourth over 11x to the fourth. I'm going to say note 4 equals 4.
Ow. You hit me. Johnson. Johnson hit me.
When I say note 4 equals 4, please don't be like, where did you get 4 from? It's right here. If you need to take your highlighter,
I need to present that.
maybe highlight. Maybe go back here. That's probably not a bad idea. 1 and 3. Like highlight what we're looking at. So because 4 equals 4, then yes, it has a horizontal asymptote. And the answer is the equation of the lead coefficients. You literally wrote it right here. It is negative 7 over 11. Now you do need to know that these are usually ugly, but they're simple. Like you just pull those numbers. That's it. I love this section. I wish it lasted longer, and I wish more people enjoyed it. But I think what happens is people just get lost in it's dense. There's a lot. In one problem, there's a lot to do. And I think that's where people get lost. So yeah, I put, for the third one, hold on. There's not another practice. There is. What's your next one say? Yeah. Okay, so now let's go to the next one where we're just practicing finding the vertical and if there's a horizontal. We've not practiced scenario 3 yet. That's okay. Go to this one. It says find all asymptotes. There's only 2 types. There's either vertical or horizontal. Your vertical comes from looking at what, y'all? Denominator. Someone make a note. Vertical. That I'm underlining. Denominator. I'm not spelling it right. Hold on. I'm trying to sit down. This is where organizing your stuff is really helpful. All right, I got my denominator equal to 0, and I'm going to solve. Notice the top there's nothing to factor here. I did this on purpose. I just wanted you focusing on finding the vertical asymptote.
So in the horizontal asymptote, is it usually only whenever there's a quadratic on both numerator and the denominator, or the leading terms degree above the
No, not
denominator?
necessarily. No. Because if you go back
You
to,
see here what Johnson.
Because this one has,
go to the mother function,
right,
what is the variable in the top? X to the 0, 1x to the 0, and then the bottom is just x to the 1 power. Is 0 less than 1? Yes. So there's a horizontal asymptote at 0.
so the one we're on right now,
The one we're on right now,
it said 2x over x plus 3.
hold on, am I there? Down there.
So,
Well, I found the vertical.
right,
So this is VA at x equals -3. Now I'm going to talk about the horizontal.
okay, I see. So,
The horizontal is your leading terms test. I like to just pull the terms and write them on paper so then I can remind. I like procedural steps because that helps me build the conceptual fluency. So I like to pull 2x, pull x, and I say to myself, hey, that's a 1, that's a 1. Ooh, 1 equals 1. Okay. Then it is the equation of the leading coefficients. That is a 2 over a 1. What is 2 over 1? 2. So, we have a vertical asymptote at -3. Watch your directions. Then we have a horizontal asymptote at 2.
Alright, so where do I go?
And I don't know why. I don't have the graph on my thing right here. You can put it in the calculator. I can just plug, let's see. This is how I plot it real quick in my mind. I plug 0 in. So that's 0 over 3, which is 0. So there's definitely a curve here. Right? And then -5, that'd be -10 over -2, which is so over -2, that'd be positive, so it's up here. Now you don't have to know how to get that sketch yet, not there yet. We might save that for Flex 2 tomorrow, like how to get the actual sketch. Right now, let's just work on being able to say, what's the domain? What's the vertical? What's the horizontal? And is there a slant? We might do that. That way it's not like,
Are we just gonna stop after this next example and then do practice?
no.
Okay. I didn't know.
Well, no, hold on, I haven't looked.
Because after this next example is our slants.
Oh no, slant's not a big deal.
Okay.
All right, now go to this one. Is this on yours?
Yeah.
Yours?
So it's basically,
I did not tell him we were checking him out, so you will have that surprise. Wait.
What?
Oh yeah. All right, repeat. Do it
It
again.
was a joke.
Tell me the vertical. Tell me the horizontal. It's the second practice problem. Find all the asymptotes. Remember to do what I said. Have some type of like systematic procedure. Be organized, and then it's going to help you to know when you're checking the boxes and doing it right.
Hello, man. I didn't. I don't know where it's at. Your seat pairs. You go back to your seat, right? This is what's. Maybe your seat quiet. I don't like peer sitting over here.
Yes, I'm very quiet.
I just don't get either of these.
Hey!
Oh,
I can't reach that. Give me a 4 on top.
All right. Should be done with the vertical, right? Verticals. Yeah. Vertical's just the what? The denominator. So set the denom equal to 0 and solve x squared equals 0. Square root that, you get 0. This is not a big deal, but I hope you tie this with when we've talked about it before. I just got 0 from an x squared. I got one answer from a squared x. Can I go with this?
Plus or minus 0.
No.
Bolt 2.
It's a repeated 0, which means there's something different about the graph. I'm going to show it to you when I sketch it. You're going to be like, okay, I get it now. It's not a big deal. My math lab is not asking you to state that it's a repeated value for the vertical. Like, you can't repeat a vertical asymptote. You draw it one time, it's there. Now, horizontal is the leading terms. You have 2x squared over x squared. I'm use my highlighter to show what I'm looking at. I'm looking at the fact that 2 equals 2, so it is y equals the coefficients. 2 over 1, which is just 2.
Well, how do we do this?
Now, let's do our graph. We got a vertical at 0. Then we got a horizontal at 2. Because this vertical asymptote is repeated, the graph is weird, it's different. Instead of them being on diagonal sections, they are both going in the same direction.
That's it.
Yeah. Oh well, no. As far as us, yeah. I want us to do the last scenario. We have not covered the last scenario, so I'm going to arrow back to that slide where I do the little 3 boxes.
You stop humming, play it, please.
Okay. We covered, this is for horizontal asymptotes, right? We covered the scenario when the numerator is less than the denominator. We only practiced it one time because you just check it and then that's the end. It's y equals 0 every time. It never changes. If the numerator is less than the denominator, 3, it's y equals 0. If they're equal, then it's the coefficients, which we practiced a few so that you would know where to pull those answers from. If the numerator is greater than the denominator, there is no horizontal asymptote. Instead, I'm going to draw an arrow coming out of the box because we're no longer talking horizontal. Instead, there is a slant. Or oblique. They're the same thing. You know your obliques? Okay, they slant. So keep those words synonymous. So if the numerator is greater than the denominator degree-wise, there is no horizontal asymptote. Instead, there is a slant. So what was the slant here?
Horizontal.
Slant. Listen, what was the slant? It's a trick question. There was none. Which means on the My Math Lab, you would have to select the box. There is no slant asymptote. And it's because there is a horizontal asymptote instead. Okay? Alright, so now let's practice how to find the slant. Save the best for last. Alright.
This looks like so much fun, Miss Holcombe.
Y'all remember long division?
You're joking.
Oh.
Remember me saying you have to know how to do long division? Enter slant asymptotes. Good news though, you don't have to finish the whole problem. You just all we care about is what's on the top. We don't care about the remainder. We don't care about finishing it all the way through.
So are we going to have like the ones with square roots?
Oh, that's not a polynomial. No. Those are just irrational zeros from a polynomial. Okay, so then this says, notice it says, find all. Notice it says find all. Alright, so let's find the vertical. I'm going to do BA. Abbreviating vertical, BA, horizontal, HA, and then slant, I'll just write the word slant. So the vertical is what again? Okay, and then set it equal to 0, solve, you get -2. Not on this particular one. No. You're good.
On one of them, like, you have to check.
I think it does back, but it doesn't. We're not doing it for right now. You're good. Do what? Yes. Yeah. You can check it if you want to. You would say. I don't think my math lab says there's a hole. I think it ends up just being in the domain. Hold on, I have my work right here. What is this? 4 or 5? They don't say on my math lab anything like there is a hole. It would end up just being part of your domain where the domain is skipping over that hole. Okay. All right. Horizontal asymptote. This is where you look at your lead terms. Remind yourself, it's the lead terms test. All right, we got 2x squared over x. This x is to what power? 1. That is a 2, that is a 1. You always do it in order. Numerator, what? Denominator. So 2 is what to 1? Greater than. Which means no horizontal asymptote. I'm moving. Instead, I'm doing an arrow to say, hey, this problem's not done because I have no horizontal, which means instead I have a slant. And I have completely run out of room.
Not this one.
Oh, I can come over here. Yep. All right, so I'll do this. This really, oh my gosh, y'all have no idea.
How much is
It's okay. Let's just power through.
You got it. Come on, let's go.
Killing my OCD. So how do you find the slant? You long divide. Okay? How do you know when to do this too? Anytime the numerator is bigger than the denominator, that means you can divide it down, right? You can break it down. That's another indicator, like, okay, I'm dividing here. I got x plus 2, long division. Probably wrote that a little too high. Okay, all right, hold on. Let's see where you're going with that. Don't forget to check for holes, gaps.
That goes on the
That
bottom.
goes underneath the.
Yeah. Y'all, you have no idea. This is killing my OCD.
It's just messing with you.
It is.
Why is there white stuff on
Huh?
You're doing the side. Just think with that right side at the top.
Oh, it's my lipstick stuff.
Aside, that's
All right.
Yes.
Now I'm sweating.
Right aside.
Okay.
It'll herald. There you go.
I used to get made fun of for my OCD. I probably still do. All right. Okay. We are going to long divide. Let me refresh you on how to do that. Remember, you're just focusing on those first terms, okay? The rest is along the ride. A long divide. Yeah? No?
No.
Okay.
Not today.
Say to yourself, x times what would give me 2x squared?
2x squared.
2x.
2x. Sorry.
Should be breaking down. Always remember the goal is break it down. So if you wrote 2x squared, you should know something's wrong. Like I'm breaking down right now because I'm out of order, but that's okay. Then you're going to multiply that back through the binomial and write it underneath. I get 2x squared plus 4x. Draw the line, change the sign. Bring it down. You get negative x, bring this down, minus 5. Here's the beauty of this long divide problem. We only need to know this next answer and then we're done with this. Repeat. X times what gives me negative x? Negative 1. Okay? Multiply the negative 1 into the x plus 2. Negative x minus 2. And you really don't even have to do, actually now that I remember, you don't even have to do this part, but I'm going to do it because it's the bottom. Draw the line, change the sign. I don't care. Right? We don't care about the remainder. The whole point of the long divide was the answer that you just found right here is your equation of your slant asymptote. Remainder doesn't matter. I never investigated it. So, slant asymptote meaning linear. We don't have a horizontal. We now have a slant asymptote. This is where you need to be thankful. My kids last year, the year before, they had to graph it by hand. Y'all's is going to be on my math lab. So I'm pretty sure yours is matching. I need to double check. I don't think they have you actually graph these. I think they have you answer the values and then pick the graph that matches, I believe. To actually graph 2x minus 1, begin with B, move it in, but remember it's an asymptote, so don't use your pencil, or make it dotted if you do. So begin with B. I'll do light. B is negative 1. Slope is rise 2, run 1. Rise 2, run 1. So you can kind of see, like, there's slant asymptote. It's a line, so it's a slanted line. Where's your curve in here for sketching purposes? It's here. No. It's here. And here. So the graph looks a little different when you got that slant in there. I want to do the next practice problem. It is just finding all the asymptotes, and once again, there is a slant. Now, the question was, can you use synthetic division? Yes and no. I get nervous to say yes because I'm worried somebody's going to hear yes and run with it. You only can use synthetic division if the denominator is a 1x plus a number or minus, you know what I mean? Like, it has to be 1x right here. It can't be 2x minus 1. Can't do synthetic division with that. If it's x plus 2, x minus 3, x plus 4, x minus 7, you can do synthetic division. You would pull that 0 out and do the synthetic division. I personally don't mind long division because I'm not afraid of it. I would encourage you to practice it because it's really not bad. But yes, you could. If you did the synthetic division here, it would have looked like this. 5. And then you'd say 2x minus 1. So, as long as you know when you can use it, I'm okay with it. So when did I say? When the denominator is 1x and then a number, you can do it. Okay, let's practice this one. and then we will call it done. Find all the asymptotes. Okay, so here we go again. We're going to do vertical, we got horizontal, and we've already said there's going to be a slant. Did you get the vertical at x equals 2? Did you get no horizontal asymptote? Which means you have more work to do. There's a slant. If you do, question, can you do a synthetic? Yes, because it's a 1x. So you could. You do have to pull the 0. So there's 2 tricks to knowing when to do the synthetic, or how to do it. Know when to do it, and remember to pull the 0. With long, you don't pull anything. Like you just run with it. Regardless, either way, you do have to check for gaps. There's no gaps though. If you did synthetic, it would look like this. You do long, so you would say x times 2x, multiply it through, draw the line, change the sign. Then you'd say x times 1. And I don't even have to keep going. So my slant is at y equals 2x plus 1. So you got a vertical at 2, 2x plus 1. So plus 1 is b, rise 2, run 1. I just like to go multiple spots so I can kind of see where the line is. I just drew an arrow. There we go. Preview of what's to come tomorrow. So don't panic here. To get where the graph is, you have to ask yourself, where could it be? Well, remember it's a function, so it cannot be stacked, right? It's a function, which means it passes the vertical line test. So while there may be 4 sections here, in terms of where you're actually putting curves, your only curves can be to the left of that or to the right. So there's only 2 sections because it has to pass the vertical line test. How do I actually find out where the curve is? I pick numbers and I plug it in. I pick numbers that are on the x-axis in those sections. So like I might plug in 1. 0 is really not being touched. I'd plug 0 in. I'd plug 3 in. And then I would get the answer and I would know, oh, okay, the curve's in that section. So that's,
Common sense.
yes.
That's it.
What's going on over there, guys?
Just not one.
Where is it here? If you plugged in
Just.
these numbers, like 1 or 0 into that function, you're going to get values down here. And then if you plug 3 in, you're going to be up here. So the curve is in those sections. Now, here's the game plan. tomorrow, second lunch. You're gonna come in and we're gonna finish these notes. Finishing means we were just practicing all of it together on one copy, okay?
Whoa, Bobby.
How many are there left?
What I say?
4?
Oh, I said so.
So there's 4 slides of practice left for tomorrow. And then we will be working on the review. I'm going to go ahead and post the solutions to the review. You already have the review, right?
You said you were gonna do
I'm talking about the packet. The test is only 17 questions because some of them take partial credit on every one. Partial credit. Who was out